Welcome back. Today we're going to cover web services. We've covered the back end and the configuration end, at least some of it, and now it's time to start closing the loop. Let's expose some services and extend the services that you already have deployed in the sandbox. Since this is a really big subject, we're going to break it into several videos. So let's start at the core. The core is the security modules in AzStudio. The first thing to know is that the configuration database, under its security modules, has the ability to completely manage the user role, group, and other aspects of security in the system. The pieces we're interested in today are the user, the role, the endpoints, and the application modules. As a side note, AzStudio can integrate with any authentication provider that you wish to link to, be it LDAP, SSO, Active Directory, Active Directory Azure. It really doesn't matter. We have the ability to put adapters in and workers in to synchronize those two systems. However, when you're building an application, we generally recommend that you keep the security data up to date in its security database so that things like stored procedures and joins and views will work correctly without having to jump through a lot of hoops to get to different databases. Also, some authentication databases are not constructed to be used as a query source. They're basically used as a source of record for authentication and role-based information. AzStudio comes with the framework to handle users, roles, endpoints, and applications. So let's talk through each piece and how it relates to service offerings. Our first piece of information that we manage are roles. Roles can be of any sort you want, and they have the ability to reference another outside system so that you can keep the role name that you have in your application synchronized with a authentication source that's the master. Basically, you're just keeping a list of role names. Each of those role names has an underlying ID. That ID is what's used to link all the other components of our security model. Users are about what you'd expect. We have a user state, a flag to set whether the password reset is required when they next log in, a latitude and longitude, a security flag to track how many times they've attempted to log in unsuccessfully, last date time the password was reset, an external system ID so that you can keep an external directory system synchronized with this table, and what time zone they belong to. Next, we have the user role manager. This allows you to manage users and the roles that they belong to. So far, that's pretty straightforward, but now we have the concept of applications. An application is, well, an application, but it can also be an aspect of your application. It can be a interface into your application that you wish to present separately from other pieces of your application. For instance, you can have an application aspect that's running on an unsecured terminal and another aspect of your application that's running on a secured terminal. Those applications can have different roles, even though they talk to the same paths array. So, applications can have roles. Just like a user can have a role, so can an application. Say your unsecured terminal can have different roles than your secured terminal application. The upshot of that is if a system administrator logged into an unsecured terminal, the matrix of rights that they would get would be based on both the application roles and the user roles. The way the matrix is calculated is that the most restrictive role set is the one that's used to offer access to the endpoints. Endpoints are how we map shortcut names to actual web service endpoints in your system. So, endpoints have a lot of interesting features. First one is endpoints can have versions. As you can see, AzStudio comes out of the box with 3 predefined version names. You can have as many as you want, and you don't have to go in sequence like this, 1.0, 2.0, 3.0. You can do 1.1 or 1.11. It really doesn't matter. Essentially, endpoint versions are defining sets of endpoints that you'll return based on what the application or the client asks for. Basically, endpoint versions are the way you version control your endpoints and depreciate older endpoints and substitute newer endpoints against the same shortcut names. Next up, we have endpoint types. You can think of these as shortcut names, just like you would in blobs or Redis cache or anything else we do in AzStudio. It's a little backwards that we're defining the shortcut first, but it'll make sense in a minute. For this training, let's add a new endpoint. Let's call it Hello World. We all like Hello World. Now we have a new type, endpoint type, in the system called Hello World. Next, we're going to assign which roles can access that endpoint. For this demo, we're going to make it an open endpoint in that anonymous users can access it. An anonymous user is a user that does not have to have a login token in order to make the call. This will keep us from having to run a login test script before we run the actual test script against the endpoint. To emphasize this, it's important to understand that both the application that's running the software, the client software, and the user who's authenticated contain at least one of the role names that are associated with access to the endpoint. Anonymous users is a special case in that everyone is an anonymous user at all times. If you start playing with the endpoint security at a later date, keep in mind that both the application and the user must belong to the role, or you will not get access to the endpoint. From this point, we can now create our mappings. Mappings are simply an environment to shortcut name to endpoint with a version number associated. That is, if somebody tries to access this endpoint in the dev environment with the 1.0 version of our API, this is the URL that should be called when the request is made. You want to create one of these entries for each environment and each version that your API supports. So you can see, this is our ping the configuration service, and we have one mapped for config, one for dev, and one for production, but not one for QA. If we tried to ping the CAS service in QA, that would most likely fail. This information drives any client that's attempting to access the AzStudio product that you're building. This includes JavaScript. That is, JavaScript will get a library back of endpoint names and URLs that they can use to call different services. This means that testing in both C# and JavaScript and any other framework will remain consistent. The only information that's actually transmitted are the models and this routing information. The technology is neutral as to what you're using for your client side and server side. In addition to per environment mapping, there are two overrides that the system supports. One is device override. If the device IDs itself and that ID matches one of these mappings you have in the database, the returned endpoints will be routed through a different environment. That is, if the device is normally in production, but you need that device to map to QA, it can identify itself as a QA device, and the environment endpoints it will get as a result will be the QA, not the production. This even goes so far as to mapping to your local machine. You can create a device ID that matches your name and an environment that maps to your local instance of IIS running, and then you can debug directly from a remote device without changing any of the code on the remote device other than the device ID it's submitting. As a matter of fact, if you submit the device ID or device UUID as a matter of course when requesting endpoints, then there isn't any programming changes you'll have to do to route that device to any point in your system, including a mix of points. You could mix say on-prem endpoints with off-prem and cloud endpoints in multiple environments to get the results you need or to have debugging occur in real time. The sky's the limit with device ID. But we also have user overrides. You can take a particular user ID in the system and an environment ID and map those two to each other. That way, no matter what device the user logs into, they'll be routed to the proper environment. If you have users that you only want to map to specifically sandboxed environments, say a less secure environment rather than a high security environment, you can force those users when they log in to map into that particular environment, no matter what the device ID, endpoint version, or application versions say. Another great trick that we use with user overrides is to have a user who's having problems in the field map to a completely new set of mappings. for instance, if I were to take the dev mappings and copy them into a special test mappings, and then reroute one of those URLs to a special debug server, and then have the user log back in, they could acquire that new environment. Everything would work as if they were in production, other than that one call, which could be routed so far as to my own desktop and into my own copy of Visual Studio, where I could have it running with the production key as well. With those two things set up, I can live debug users or devices in the field at my desktop, no matter where they are. So that's a lot of information to digest. The bottom line is that there is a call called getEndpoints, and getEndpoints returns our mappings based on the information delivered in that call. That information coming back as mappings is a dictionary, one side being the endpoint name, which is your key, and the other side being the endpoint, the URL of that call, being the data. No matter who's consuming it, whether it be AzStudio, JavaScript, Ruby, anything that you'd want on the client side, they can all consume that dictionary the same way and use it to look up the endpoints without having to hard code anything. So the first step in securing your endpoint and exposing it to the outside world is to make sure that you have the proper user account and application account mapped to the proper role. Then create an endpoint type, add the end rights to that endpoint, and map it to a URL. As you can see in our mappings editor, we haven't created one for Hello World yet. Let's put a placeholder here. Great, we have everything except the actual URL, and that's because we haven't written it yet. After we write it, we'll be able to substitute this value later. Another thing to note, and it's very important, is that the data source for this information is the config database that you're currently connected to. Now in your sandbox, there's only one of those, config database. But if you're managing multiple products or multiple applications, and each one of those has their own configuration source, you need to make sure that you're pointing to the correct configuration source, or these endpoints won't be there when you ask for them later. The first step in creating a set of tests for your endpoints is to create a test set. In this case, we've created a sandbox set and given it an endpoint URL to acquire the actual dictionary of endpoints. When you use JavaScript or any other client other than AzStudio, this endpoints URL must be coded into the client. It's the only piece that needs to be coded in order for the system to work. All of the other calls are used via the dictionary. Notice we have an application ID, a version ID, and even a device ID that can be placed into this set, thus changing what endpoints you see. The user ID, of course, is only known when the user logs in. Now let's watch the system in operation. We'll open up our logging window extra wide just to see this work, and we'll test the getEndpoints. The getEndpoints function is going to come back and give us all the endpoints that are allowed to be called by an anonymous user. The reason you only get back the anonymous user endpoints is because you're not logged in yet. You have no authentication. So based on the base information that you've given from the set, this is what the system thinks that you should be able to call in the system. And you'll notice the endpoint hello world and that temporary URL is returned as part of this set. So it is possible to call it. It just won't do anything right now. Later, once we write our web service and have it running on our desktop, we'll map this URL to that endpoint and try actually calling it. For now, that's enough to digest. Play around with the REST test sets and all the security modules in the security menu, and familiarize yourself with setting up an endpoint, or at least what data is there, and see the patterns and understand what's going on under the hood. Thanks for watching.